Good afternoon. Let's now switch from theory to practice and look at a real world implementation of Pega Live Data. Lab Data Workflow is an application that was built in phases. In first phase of our implementation, we were focused solely on the case management side of the application. We weren't really focused on what the integration layer for this application would look like and what it would actually take in terms of the integration types to make that integration happen. Good afternoon. Let's now switch from theory to practice and look at a real implementation of Pega Live Data. Lab Data Workflow LDW was an application that was implemented in phases. In phase one of our implementation, we were focused solely on the case management layer of this application. We weren't really aware of what it would take to build our integration layer at this point of time, but we were really interested in understanding the business requirements that this application needed to address. So in this phase, for example, we knew that there would be an external application that would be initiating that batch in Pega, and we also knew that after batch intake was complete, it is something that would be submitted to another application for further processing. However, we did not really know what the physical data model for these applications looked like or what types of integrations would we need to do to integrate with these external systems. In phase two, we are focused on the integration side of things. So now we know ELN or Electronic Lab Notebook would be the application we would be integrating with to create a batch in LDW, and JMS messaging is what we would use to make that integration happen. In addition to that, after the batch is successfully completed in Pega, it would be sent to LIMS or Lab Information Management System for further processing, and this integration would be performed using SOAP, web services, and JMS messages. One of the other things that we discovered during this phase was that in addition to these two systems, we would also need to integrate with a third system called PD Hub, which is where reference data is housed at BMS, and this integration would be performed using REST web services. So one of the key learning for us during this exercise was that the integration layer of an application is prone to change, and this change can happen independent of the business requirements that the application is implementing. We have used Pega's live data capabilities to shield our application from some of these changes, and that's exactly what I want to demonstrate to you today. So with that, let's jump right into it. So what you're looking at right now is the developer portal in Pega 7. We also call it the Designer Studio. This is where configuration for an application is done by the development team. It has a number of landing pages that allow easy configuration of various aspects of an application, and two of those landing pages that are more relevant to our discussion today are cases and data. Let's look at those. The cases landing page can be launched using this button on the left panel, and as I launch it, it presents me all the case types that are configured for this application. So for this application, I have the batch, container, aliquot, and tests. If I select any of these case types, it opens that case type in what we call the case designer, and this is what I use for configuring the various stages and the processes associated with those stages for my application, really implementing the workflow for each of these case types. So if you recall, I talked about us being focused on implementation of the case management for the application in phase one. This is the tool that we used for doing that. The data designer is where I design the various data types for my application. So right now, what you're seeing is a list of all the data types that are defined for my application, and I can select any of these data types, which will result in that data type being opened in a data designer. The data designer is where I define the various attributes for that particular data type. So for example, in this case, I'm working with a batch data type. I would be using the designer to design things like the composition for that data type, like what are the attributes, properties for that particular data type? What are some of the sources for that data types? And what do the records for that data types look like? Now this is in contrast to how you would be designing a data model in a traditional application, where you would be thinking more in terms of classes and properties and even what the physical model for that data would look like in a database when you're designing your data model for the application. This is using more of a visual representation for defining your data types. We think this approach is far superior, and the reason it is superior is because when I'm using this data designer for designing the data model for my application, I'm thinking more in terms of how this data model is going to support the case management functions that it needs to support, right? What should the data model actually look like to actually support the business logic that is being implemented for the application? And because I'm thinking of those things, this data model that is being generated maps more closely to the domain that I'm working in. And because of that, ultimately this data model or the logical data models that is going to be created with these data types is going to be more adaptable to changing business requirements. The data designer has a number of powerful tools at the disposal of a designer. One of my favorite ones is the data visualizer. I click on this button on the top panel to launch the data visualizer, and what the data visualizer provides me is a visual representation of that particular data type. It gives me information and it gives me information for that data type on two different aspects. The first thing it tells me is what is the key composition of that data type. And the second thing it's telling me is how is that data type actually related to the various other data types and cases in my application. So for example, over here, I'm working on a batch data type, and what the data designer is telling me, or what the data visualizer is telling me, is that this data type is composed of a list of containers. I can further drill down into these containers and see what are these containers composed of, and I can further navigate the relationships if I decide to do so. So in essence, the data visualizer is presenting a visual representation of a data type, which is allowing me to really gain a deeper insight into how that data type is being used in my application. Let's now go ahead and create a batch and see live data in action. As I launch the batch, the first thing I'm prompted for is a product code. This is using an autocomplete control, so I can just hit the down arrow to present a list of all the project codes that I can select from. And this information is being fetched from a live data source, integrating with a system of record called PD Hub. This integration is performed with the use of a rule type called data pages, and that rule type is extremely useful when we are implementing live data in Pega. So let's open up that rule type or that data page and see how that information is being fetched. The data page really is the heart and soul of Pega Live Data. It is this rule type that defines or that allows me to maintain that separation between the logical data model defined in the application and the physical data model where the data is actually being stored, and allow these two layers to evolve independently. So how does it actually do that? The data page definition consists of two sections. The first one is called the data page definition itself, and the second one is called data sources. The data page definition is defining the structure of the data that this data page is housing. So it has a number of prompts. As you can see, the first one is talking about whether the information that this data page is housing is a page or a list, is a single or multiple entries. It then defines the object type, or what is the type of my logical data model that this data page is going to basically house. It defines the edit mode, whether this data page is read-only or editable. And then finally it defines the scope of the data page, which really is talking about things like, is this data page going to be used by a single user, or is this something that's going to be shared across all users of an application? The data sources is where it gets a little more interesting. This is where I'm defining a data source, which really dictates where and how this information is being fetched from. So in this case, for example, I have a REST connector that I'm using to get this information from an external database. And this is essentially going to be calling a REST service for fetching this information. In addition to fetching this information using a REST service, it also has a response data transform configured, which is responsible for mapping that physical data model that's going to be returned by the service to the logical data model that my application can consume. So this is where it is creating that necessary separation between my logical and physical data models. In addition to allowing me to keep these data models separate, one of the things it is also doing is making it extremely easy to change data sources that are being used to fetch information. So in this case, for example, let us say instead of using a REST service to fetch this information, I want to go ahead and set some simulated data for this data page. Well, that would be as easy as checking this checkbox over here, which says simulated data source. And when I do that, it gives me a list of data transformation rules that I can select from that basically allow me to set simulated data that would be returned by this data page. So in this case, I have a data transformation rule that is configured to set 5 dummy project codes for this particular data page. I'll go ahead and save this change. And if I go back to my UI and now get a list of project codes, you can see that instead of getting a list of hundreds of project codes from an actual system of record, it's returning me 5 dummy values. Let's take a look at this again. I go back to my data page. This time I'm going to turn off the simulation so it actually goes ahead and uses an actual REST service call to fetch information from the system of record. I'm going to save this change, go back to my data page, and this time I'm getting a list of all the project codes from the system of record. So it may be incredibly easy to change data sources when you're using data pages, but what's the benefit of doing that, right? I mean, what is that buying me as an application designer? Well, in our case, the benefits were pretty obvious. We want to build out an application without having any integrations in place. So what data pages allowed us to do was build that application out and simulate data in all the integration points for that application. So we build out the workflow, we build out the UI. Supporting that workflow, we build out the validation rules for implementation of that business logic. And pretty much all of that was done by simulating information when it came to integration with external data sources, right? And not only were we able to build out that entire workflow, pretty much what we did was totally and completely reusable when we actually went ahead and integrated with actual data sources in the client system of record. So that really is the power of data pages and Pega Live Data Engine. It is making your application agile so it can adapt to integration requirements and physical data models that can potentially and likely will change over time. Let's go ahead and run this application now and see how it is integrating with live data for the client and still preserving the workflow, the UI, the validation rules that were defined in phase 1 of the application. So in this case, I'm going to go ahead and select a project code, provide a unique batch ID, go ahead and create a batch with a single container, selecting a compound. And now I'm going to provide the information for the single container that this batch has. So all this information now in terms of the purpose for this particular sample, the grade, the band, the storage condition, etc., it is all coming from live data sources as opposed to being simulated, which is what we did in phase 1. The next screen is going to present me a list of tests. Again, the data source has been switched from simulated data to using actual live data from a client system of record. Go to the next page. The courier information is pretty static. The hazards are pretty static as of now. I'm going to finish this and I'm going to submit this container to the system of record. And when I do that, the difference this time is instead of that being a dummy simulated submission, I'm actually submitting this information to the system of record called LIMS for further processing. So what you've just seen is how an end-to-end workflow can adapt quickly and easily to changing integration requirements using Pega Live Data capabilities. But live data cannot just be used for implementing workflow requirements. It is something that can be used for other areas of your application as well. Here's an example of where we are doing exactly that. The UI that you're looking at is a dashboard for a batch. It has a number of sections that configure and display various aspects of that batch that the end user needs to see at a glance. So my work list, for example, provides the actions that the user needs to perform when he's working on this batch. And this is information that is sourced from the cloud data store. Test results are results for the tests that have completed execution, and this information is coming from ELN. The work parties is having information about the users who are associated with this batch. It's just a requester in this case. And then it is presenting the email address, the phone number of those users, and that information is housed or fetched from a user directory at BMS. So as you can see, this UI is pretty complex in that it is fetching data from multiple disparate data sources, aggregating all that information, and then presenting it on a single UI. One of the things I think we can easily agree on is that it would be pretty beneficial if this UI could easily adapt to changing integration requirements. And that's exactly what we have done using live data. So all the data that you're seeing on the UI right now is sourced using data pages, and therefore if any of that information source changes, so for example right now these results may be coming from ELN, but down the line if for some reason these results need to be fetched from the LIMS system, that change would be limited to changing the data source that is defined on the data page that is fetching this information. Beyond that, there would be no changes required on the UI or any other implementation of this application. So, in summary, what we have just seen is that Pega Live Data is something that can be used to address real-world